Dear children, please write. Multiplexer is a combinational circuit with n select lines and 2 to the power n input lines. It directs one of the input selected on a single output line. Its application is within switches and routers. जो आपके नेटवर्क राउटर्स होते हैं, these are used there, and basically these are used in controlling congestion control congestion control. So basically, when you are having multiple input lines and when you want to process only one input at a time, you need multiplexer. So here now, first of all, I'm just going to show you how you can design multiplexer. So first of all, I would like to show you the truth table. These are the lines for the input. And here suppose we have this is A, this is B, and this is C. There are 3 inputs, so there will be 8 combinations. And one more. Now here what to do is, we need to fill that. So basically the combinations will be like this: 0, 0, 0, 0, 0, and this is 1, 0, 1, 0, and 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and here it is 1, 1, 1. So these are the 8 combinations. Now what you need to do is, you need to just have one more line for the output. And that is that we are going to represent using capital S. One thing you have to remember, that the truth table of multiplexer and the truth table of decoder is exactly same. So here we can write S0, as this is going to represent 0 here. This is S1, this is S2, this is S3, S4, S5, S6, and this one is S7. What? No, it's okay. You just design this one, and this is common in case of decoder and multiplexer. So better you should go with this. So if any problem with this truth table, please tell. And after that, I'm just going to explain you the circuit diagram. Any problem? Children, okay. Now I'm going to design that diagram here. So you will be needing that here 3 lines are needed, and basically these are the select lines. Okay. So first of all, this one is representing the first input, this is representing the second input, this is representing the third input. And here we are needing this NOT gate. This is NOT gate. So I'm just needing this NOT gate so that I can get the complement of these values. And what I need to do is just to join this. I hope it's very much clear that if 1 is being passed along this line, then obviously 0 will come along this line. And if 0 we are passing along this line, then 1 will come along this line. Okay. Now, if you focus on that truth table, how many combinations are there? There are 8 combinations. So we have 8 NAND gates. We are having 8 NAND gates here. I need to extend the line a little bit because the 8th one I have to draw. Okay, so one more is this one which has come. And now you have to design, you have to connect. And how to connect, I hope you all know how to design decoder. So in that case, this very first gate is representing 0, 0, 0. So I need to connect this with 0. This is how we have connected. And in a similar way, this one is 0, 0, 1. So 0, 0, and this one is 1. For our convenience, we can write here 0, 0, 0, 0, 0, 1, 0, 1, 0, 0 1 1, and here 1 0 0, 1 0 1. This one is 1 1 0, and finally it is 1 1 1. So these are the values which are being represented by these gates. So this one is 0 1 0. So if it is 0 1 0, so this one is 0. This one is 1, and this one is 0. This is 0 1 1, so it is connected with this 0, and this one is connected with 1, and this one is also connected with 1. This one is 1 0 0. So 1, 0 0. This one is 1 0 1, 1 0 1, and this one is 1 1 0. And finally it is 1 1 1, so it is like this. Till now I have designed a decoder. It is not a multiplexer. I need to add few things in it, so it will become a multiplexer. So I just need one OR gate, and here within this OR I need to pass every. So what is happening here? Suppose I am passing 000, so whatever value this very first gate is representing will forwarded along this line and will move forward. And here this circuit is being represented within the network router. Now the question is from where that input will come. So I need to just define some inputs like I0. So this is the first input, I0, I1, I2, I3. These are the inputs which will be passed. 4, 5, 0, 1, 2, 3, 4, 5, and 6, 7. These are the inputs. Okay. Now what I need to do is, children, just to connect these input with these these gates. So just suppose it is I0, so a line here will be there and it will get connected with this gate. In a similar way, there is another line which is connected with the second one representing I1, and here there is another line which is connecting the third one, and this is for I3, and here it is for I4. Wait. I hope you people have understood and easily you can construct. It is I4 connected and this is I5 which is connected, and finally I6 and I7. This is I6 and this is I7. So children, this is multiplexer. So multiplexer is a combination circuit which is having n select lines, and these select lines are these one, n select lines, and the same is having 2 to the power n input lines. So if there are 3 select lines, so there will be 8 inputs. So these inputs we have got here. So if I am passing triple one, it simply means the input at this point will get forwarded along this way on this wire further. So if you people have any doubt, then please ask. This is all about multiplexer. So like decoder, you have to design and then you have to connect the input lines, and one more additional OR gate will be there, and further a single output line you have to draw. That's it. Yes. Any other issue? Aradhya Khanna, understood? Aradhya? Okay. Shashank Kumar, Atindro, Dev Kapoor. Yes. Any problem beta with multiplexer? Okay. Now children, what you want for revision? Which topic? Okay. So anything else from Boolean algebra? You want, okay, let us discuss that full adder using two half adders. Okay. So first of all, I need to design full adder, so half adder. So this is the very first line, and this is the second line. And actually here, this first line is A, representing this A, and this second line is representing this B. In order to represent the sum, we have one XOR, so which is this one, and in order to represent the carry, we have this AND gate. So what you need to do is just to draw. So here first of all this one, and here you have joined these two wires. This is connected and further this is connected. So children, this is half adder. Till now any doubt? And if you write the Boolean expression, so at this point, what is coming? At this point, A complement B plus AB complement is coming, which is XOR. And at this point, which is the carry part, AB is coming. Any doubt? If any doubt, then please tell. Okay. Further, what is needed? We need the third bit, because 2 bits we have already added. So that third bit will go like this. Sorry, this is the sum only, and third bit we will be needing. So that is the third bit, which is C. and this C is coming along this way like this, and further this is, and here this I need. Here that is XOR, which is representing the sum here, and for that carry we need this wire, and here we are needing one AND gate, and further this will get passed, and here we will be needing one OR gate. So children, here finally we will be getting the sum. Sum we are getting here, which is this, and carry we are getting here. So if there is any doubt, then please tell. A complement B plus AB complement, and this is being represented here, and this AB is coming here. So children, if any doubt, then please tell. Any doubt? I'm just going to explain this part because till now I have not explained. This part is actually C, the third part, third input. So if you focus on this one, this line, it is the output which is coming like A complement B plus AB complement, and here I am getting C. So at this point I am getting C within bracket A complement B plus AB complement. We are getting this. And at this point we are receiving AB, and at carry part we are receiving AB plus C, A complement B plus AB complement. We are getting this. Children, in order to calculate the sum, there is no complex calculation, because whenever you add one bit within the resultant XOR, suppose XOR is representing the sum of two bits, and if you pass that XOR along with one more bit C in another XOR, the sum of 3 bits will get calculated. Further, if you pass this XOR and along with another fourth bit, so the sum of 4 bit will get calculated. So there is no issue with the sum. Problem there is with the carry part. So you have to prove that. So for the carry, it is like AB plus C, A complement B plus AB complement. This is the actually expression for carry. And this is what we have to prove. We have to see that. Now I am going to just prove this one only. Children, first of all, if you have got AB plus that C, A complement B plus AB complement, further it can be written as A complement BC plus AB complement C. Now if you take common, what you can get? You get C as common. But uh, here you can get A as common, no, B as common, and you can write A plus A complement C plus A B complement C. So here this is what distributive law, which tells us if A plus A complement C, then it can be written as A plus C, as the dominant term is A. So further it can be written as AB plus BC plus AB complement C. Now here it is AB plus, take C as common, and it can be written as B plus B complement A. This can be written like this. So now what to do is, it is AB plus C, and here you can write A plus B, because B complement will get eliminated. Using the distributive law again, that is B plus B complement A is equals to B plus A. So I have written that A plus B, so which is equivalent to B plus A. Now further I can write AB plus AC plus BC. This is the expression for the carry, which is this one. So this is how we have implemented full adder using two half adders. So now if there is any confusion, children, you can just take the screenshot also of this diagram along with this proving. So please take the screenshot. Yes. Any other issue? Any other query in Boolean algebra, children? Any query in, I hope you all have taken the screenshot. Okay, so any other issue, any other problem with Boolean algebra? If there is any issue, then please tell. Shreya Agarwal is here. Shreya Agarwal. Okay. So after Boolean algebra, children, which topic you want to revise? Beta, please tell. Am I audible or not? Okay. Only you want recursion or others also? Because others are not replying. Vinayak Saxena, are you there? Okay, what are recursive functions? Anybody please tell? Any function is said to be recursive if it calls itself. Any function is said to be recursive if it calls itself. And there has to be a base case, and base case is actually the condition when the control will leave the recursive function body. So few functions, one or two functions we are going to discuss today, and rest of the functions we will be discussing in the next class. So just wait for 1 minute. The ID is being initialized. Children, just 1 minute. Okay, so here okay. So children, the first recursive function which I am just going to explain you, the sum of n natural terms. So this is the function interterm, and this is the limit I am passing here. Sarthak Manral. In this, I would like to suppose I am just passing the value of n5. It is not. Sarthak Manral. Children, suppose I am passing a value n is equals to 5, and here I would like to just calculate 1 plus 2 plus 3 plus 4 plus 5. What I should do? First of all, we have to, yes, sir, we have to just write the base case. Beta, you are Sarthak Manral. Sarthak Manral, are you there? Sarthak Manral, I am asking. Parv Pandey. Parv Pandey. What will be the base case? The base case will be if n is 0. It is the situation when the value of n becomes 0, and in that case we need to return the value 0 here. And if not, then we have to execute the rest of the part. So that is n plus term n minus 1. This is the function which will add n natural numbers. Main method. And here enter limit, and that is representing actually the limit of that up to which term you want that sum. So here you have received that limit, and here this is the variable for the total, and now you are going to call that function example dot term and passing this n. And after that, here you can just total is that total. So children, if you execute this code, and suppose you are passing 5, the sum will be 15. And how it is coming? How it is coming, children? See that here you have passed 5 and it will receive 5, and this n is not 0, this base case is not true. So what will happen? Here this statement will get executed, so which is 5 plus, and again another function call, you are passing term 4. So again the base case is not true, so the expression will become 5 plus 4 plus that term 3. In a similar way it will get executed, and further it will become 5 plus 4 plus 3 plus term 2, close all the brackets, and further it will become 5 plus 3 plus 2 plus 1, and then it becomes 5 plus 4 plus 3 plus 2 plus 1 plus within bracket term 0. So when the value of n becomes 0, this condition becomes false, and this 0 also will get added with that resultant. This is how the sum 15 is being returned. One thing I would like to tell you, that if the value is 5, it is 15, but here if you are returning 10, so this 10 also will get added within that. So here in this case the sum will become 25, because actually the sum was up to n natural numbers was 15, but this 10 also got added in that. So it's my humble request to all of you, please revise class 11th recursive functions which you have. I hope you all have your class 11th copy notebook, you all have. So please do a proper revision, and in the next class we will be revising recursive functions properly. So now I'm just providing you the Google form link for the attendance. So kindly mark your attendance there in your chat box I am providing. So please, all of you, please mark your attendance, and if any problem then please tell. If you have any query, then ask. Otherwise, after filling the